Maybe the first thing we should do is realize what is a rational equation, because the name rational sounds a little nasty. Rational just means fraction. Okay, rational means fraction. I don't know if that makes it better for you, but we're going to solve equations that involve fractions. Listen, these tend to be the kinds of problems that sometimes we never get to, like last year or 2 years, whatever. Like, it's just kind of like you never seem to get to these. We get to them this year. All right, they don't have to be complicated, but they do require a special technique. And I want to kind of show you that technique through an easier problem, and then we'll take this technique and we'll use it for some trickier problems. All right, so I got a lot to say. I want to help you guys understand quite a bit about this equation. Let's take a look at it. We got x over 6 plus 2 over 5 equals 1 over 3. When we're all done with this lesson, you would go back to this problem and you probably would say that is not really that tough a problem. But it does allow us to talk about quite a few things that we can use when the problem does get tough. Okay? Not to state the obvious, but they're fractions because they have denominators. Denominators are what make fractions fractions. Well, what we actually want to do is we want to clear the denominators. We actually want to get rid of the denominators. Now, I can't just go through here and erase them. You know that obviously would not satisfy algebra. But what I can do is multiply by some number that's going to clear those denominators. Now, the number that I'm going to multiply by is going to have to be just the right number. And I'm kind of wondering if a number pops in your mind, if you are, if you're just thinking, maybe if I multiplied by, and by chance, does a number come to mind? Okay, your response is not abnormal. Okay, a lot of times kids aren't really sure, but what if I tell you, I'm just curious, again, if you're really thinking, what if I tell you that it is, in fact, the number 30? Okay, does that make you say, that's the number I was thinking, or maybe you're more wondering why the number 30? Okay, listen, the reason the number 30 is just the right number is because when I multiply it, it's going to clear every one of those denominators. Okay, now before we do that, let's talk about where the number 30 came from, because it isn't just we got lucky. Okay, in fact, what I'm about to show you is the main part of today's lesson. It actually comes from the factors. There's that math word again, but it comes from the factors of the denominators. Now, what do I mean? I mean the numbers that multiply to be 6. So in your brain, you should be saying, okay, the numbers that multiply to be 6 would be like 3 and 2. Notice that I'm factoring it to its prime factors. That means I'm kind of taking it down to like the smallest numbers. 5. It's already a prime number. Bottom line is it doesn't really have any factors besides itself. Now the number 1, but that doesn't make a difference. You don't need to worry about the number 1. It's actually the same thing with the number 3. It's already its factor. It's already prime. Now keep watching, okay, because carefully thinking about these factors will help us to get the number 30. And here's how. I just need each one of them represented. Now, I'm using a word there that you're going to hear a little more today. I need each one of these represented. What does that mean? Well, I need a 3 represented. So, represent 3. I need a 2 represented. Represent. I need a 2. By the way, notice that I'm attaching these factors by multiplying. I need a 5 represented. So far, it seems like I'm just kind of writing down these factors. I am, until I get to this 3. Now listen carefully. Again, this is kind of like the main thing in today's lesson. I need a 3 represented. It's already represented. I already have a 3 in my list of factors, so I don't need another one. It's already represented. Now, as I'm sure you can see, these 3 numbers equal 30. Okay, and 30 is, it actually has a little title. It's called the LCD. Maybe there was a time in some past math where you talked about stuff like an LCD. I never kind of got all those things straight. Honestly, as a student, I'd be confused. LCD, GCF, ABC, 1, 2, 3. But LCD stands for least common denominator. Okay. Today, you just need to be able to find it. You find it by thinking of the factors. We'll talk a little more about that. Let's take the number 30 and let's do what you're always going to do. You're going to multiply it. Now, you want to notice in this example how I'm multiplying by 30. And simply, I'm multiplying it to the numerators. It's interesting. The number 30 came from the denominators. But when I multiply it to the numerators. That's always the way it works. Because now we can cancel, we can clear, we can cross off the denominators. Okay? We can cancel, we can clear, we can cross off the denominators. So 30 over 6 obviously turns into 5, but by denominator. Okay? 2 times 30 over 5, I mean, you can multiply that to be 60, but basically 60 divided by 5 becomes 12 by denominator. And over here, obviously we get 10. All the denominators are gone. And you're staring at a pretty easy equation. Right? Subtract 12, divide by 5. Subtract 12, get negative 2. Divide by 5. All right, we get negative 2/5. Not a big deal. Okay, but what was a big deal is this whole thing called the LCD. Now, the LCD is going to help us to solve rational equations if we just multiply. Okay, if you just multiply, as I often say, make sure you understand that. You can write it down if you want to, but ultimately make sure you understand that we're going to multiply by the LCD. What most students, though, tend to write down or focus on is this idea of representing. I like that word represent. It kind of gives us the idea that we have to make sure that each factor, or as I wrote here, all factors are represented from each denominator. All factors are represented from each denominator. Okay, there's one other kind of little nugget. It was talked about yesterday. It's kind of one of those things that it shows up again today. Checking your answer. Ah, darn, you got to check your answer. Good news, you only have to check for a 0 in the denominator. I'll show you what I mean by that, but it actually is like a shortcut. You only have to check for a 0 in the denominator. Okay, you don't actually have to go back through and sort of painstakingly check every part of the equation. But again, I'll show you when we get to a problem that makes a little more sense for that. Now, this is a rational equation. Honestly, it's of a little different variety because x is now in the denominator. So now that x is in the denominator, we have to make haste of this LCD method. Okay, so yes, it's a little bit of a trickier problem. Okay, but the good news is all you got to do is represent each factor. Let me kind of help you think about factors. 1 over x squared. Well, the factors of x squared you want to be thinking are like x and x. See how I actually listed both of them? That's because both of those factors are needed to represent an x squared. Now, the number 4 also has factors. Don't think of it as 4 times 1. Not 4 times 1, but rather 2 times 2. You want to always break it down to its prime factors. It's kind of the same thing with the number 8. Yes, the number 8 is 4 times 2, but the number 4 is 2 times 2. So sooner than later, we have to think of the number 8 as 2, 2, 2. I'm not going to give you giant numbers, but you get the idea that you have to think of all those numbers. Now, the letter x also counts as a factor. So I have 2, 2, 2, and x. Represent. I need an x and an x. Careful, I need all of those factors represented to account for an x squared. So again, I need an x and an x. I'm going to leave a little space here because I want to put the final answer beside it. Now, I need a 2 and a 2. I need both of those represented to account for this 4. Here's where we want to be careful. Okay, how you doing? Sort of what are you thinking I'm going to say here? I need 3 2's represented. Ooh, I need 3 2's. Well, I already have 2. So all that's needed is 1 more, because now I have 3 2's represented in my LCD. I need an x. I got one. Okay, I don't need another one. You see, it's the least common denominator, so I don't want to add extra parts to it. I just need the least amount. So, of course, we end up with 8x squared. 8x squared. Now, some of you, maybe all of you, sooner than later, you'll say, I could just kind of come up with 8x squared without doing all this listing. That is fine, okay? I'm actually kind of hope that you can get there. It's okay if you don't. If you want to list stuff, that's fine too. But what I'm sharing is, however you can get to 8x squared is okay with me, because 8x squared is the magic number that's going to multiply to each fraction, right? It's going to multiply to each fraction. And it's going to cancel with each denominator. Okay, so 8x squared is now in each numerator. But the real reason behind all this is so that we can cancel each denominator. So bye-bye that denominator. That leaves us with just 8. This denominator reduces. So that leaves us with minus 2x squared. And over here, be careful, the 8's completely cancel, but the x's, although the denominator cancels, we're still left with an x in the numerator. Okay, that's what the LCD does. It cancels the denominator. And it leaves us with an equation that we usually say is solvable using some kind of more basic algebra. Now, when I say basic, that doesn't mean like it's supposed to be easy. In fact, you should be looking at this equation and what method is needed to solve something like 8 minus 2x squared equals x? Just sit it on the, right there. They're in her mailbox. Seriously, what method is required for solving this equation? Now, if you're kind of frozen on that, make sure that you're thinking big. Okay, we just got done with about 6 days talking about this kind of equation. It's a polynomial. It wants to equal 0. Give it what it wants. That's what it needs, to equal 0. Now, when this thing equals 0, it's a lot easier if the 2x squared is positive. Normally, you want the leading number to be positive. It just makes it easier to solve. So I'm going to scoot everything over to the right side. Now that thing's equal to 0. And what? Again, same thing. If you're a little frozen on that, you have to realize we have the quadratic formula, which turns out to be what we're going to do. We also have factoring. It turns out that it doesn't factor. How do you know that? Just by experience. But yeah, we need the quadratic formula to finish this problem. And that's why we studied it the last 6 days. Listen, just to save a little bit of time, I assume that you can plug in the opposite of b, blah, blah, blah. So I'm just going to kind of give you the final results. Probably not too surprising. You get -1 plus or minus. The whole b squared minus 4ac comes out to be 65. It's all over 2a, so I guess that's actually all over 4. We can get an answer like that, okay? It's called a conjugate. Conjugate just means the plus or minus. You don't need to turn it into a decimal. I do want to comment real quickly, though, on this check your solution thing. It's good news. I don't need to turn that into a decimal and plug it back in like yesterday. All I got to do is make sure that it would not give me a 0 in the denominator. Now listen, there's only one number, if I plug it in right there, that's going to give me a 0 in the denominator. It's the number 0. I'm pretty sure that ain't equal to 0. Same thing here. The only number that if I plug it in, that gives me a 0 in the denominator is the number 0. So we're good. Okay, we don't actually have to do all the hard work of checking that. I know I'm going a little bit slowly. Okay, we're kind of cruising. Everybody's back on the boat. We're taking it easy. I want to make sure that you're getting the idea. But I hope you're still with me. And this problem, at times students will start to say, I'm catching on. I hope. I want you to catch on. Okay, that thing's pretty rational. It's got x's in different places. It's got denominators. Oh my. But if you think about the factors, now, again, you might get to a point where you're like, I don't really need to write that. That's fine. The factors of x is just x. Now, this guy right here, I want you to think of it that way. I want you to think of it as a group, as a binomial. Honestly, the factor is itself, x minus 4. Don't break down the number 4. It's not a number that's being multiplied. So because of the subtraction sign, I have to think this way. Are you surprised to see this kind of factoring? You know, like take out an x. That's how I have to think of that denominator, as x and x minus 4. Represent x, represent. X minus 4, represent. Again, do you know what I'm going to say? They're already represented. I need an x. I got it. I need an x minus 4. I got it. So the LCD is just an x and an x minus 4. Now, if you're at a point where you feel like, okay, sounds good, do you want to multiply it? Are you at a point where you're say, all you really have to do is recopy. It's actually kind of laborious. You basically are recopying these two guys on each of these fractions. But try it if you're comfortable. If you want to wait, I'll show you. Maybe you can already see that it's going to cancel. If you're one of my students that already see what's going to cancel, then maybe you want to skip a step and just cancel. But be careful. Okay, just for example, I honestly just recopied the yellow, or the white, and I added the yellow. Okay, I'm going to go through and do that for each one of them. Like I said, what really is going to happen here is some canceling. Do you see it? Are you saying, can I cancel right now? Okay, so we're trying to be careful, keep track of everything, but it's cancel time. The X is canceled. That's good, but you have to keep track of what's left. you're still left with x plus 4, x minus 4. X minus 4 cancels. That's good, but I'm still left with 3x. And now, in the case of this one, you have to recognize that it all cancels, but you're still left with negative 16. Okay, bye-bye denominator. All the denominators are gone. Listen, at this point, you kind of have to be ready for whatever gets thrown at you. Like here I have something that should be FOILed. I hope that you write it as x squared minus 16. But, now what? I don't know. Whatever's kind of thrown at you here, there should be something inside of you that says polynomial. Yeah, a lot of times you end up with a polynomial. That means it wants to equal 0. Make it or give it what it wants. It wants to equal 0. It looks like this negative 16s cancel anyway. This is a little bit like the one homework problem. What was it, number 4? When you get to this type of quantity and you think about factoring, please don't overthink. It's just simple factoring. Take out an x, and you get x plus 3. Remember, you're doing all this because you're trying to solve it. So finish, you get x equals 0, you get x equals negative 3. So we have to actually get those solutions. Now, remember this check thing? Okay, this is a good example of, hold on a second, x equals 0. If I start plugging that back in up here, there's one place where I get a big gooner, right there. If I plug 0 back into this equation, can't do it there. That means you can't do it anywhere. That means that 0 is actually extraneous. Like we said yesterday, just cross it off. Listen, negative 3, I can freely plug it in. That does not give you a 0. I can plug it in there, I'll get negative 7. And kind of the same thing here. You can plug in negative 3 into the denominator. It's going to check in the whole equation. You can check it in the whole equation if you want, but like I said, you only really have to check for a 0 in the denominator. All right, you guys have been good sports, but if I don't show you this, it's actually maybe the easiest problem today. If I don't show you this, you'll make some problems a little too hard. So why is this supposed to be a little bit of an easier problem? 4 over x minus 2, 1 over x plus 5. Can you do like an LCD thing? Yes, you can think about the denominators, but there was something that I'm sure that you learned back in junior high or grade school that everybody likes to do now and then, and we kind of want to say it can work today. It's cross-multiplying. Cross-multiplying is really just a different way to clear the denominator. Okay, and it only works when you have single fraction equal single fraction. But yeah, why wouldn't you cross-multiply? It's probably a little easier than thinking about the LCD, but it gives us the same result. And in this case, obviously, a pretty basic equation to finish out. All right, you might see a problem to cross-multiply. Just be careful. The rest of the problems we did this morning would not fit into this style. So don't suddenly cross-multiply everything. All right, it looks like 3x equals negative 22. So that's why x equals negative 22 over 3. It's a fraction, not a big deal. You still need to check for a 0 in the denominator. Just to be clear, the only number that would be bad would be the number 2 or the number negative 5. But again, that obviously does not equal those numbers. We're going to actually talk a little more about rational equations tomorrow, but this is a good stopping point today. All right, so there's a little homework helper. It's kind of been the style lately. It's just what's been working. So Please spend a little bit of time with the homework helper. If for some reason you didn't turn something in, I hope that you finish it and still complete it. The polynomial assignment is mainly what I'm referring to. Make sure that you finish that.